Alright, I welcome you all to my channel. In this video, I'll be showing you how to simplify Boolean expressions. I'll be introducing you to the concept of Boolean algebra. We'll talk on truth tables, Boolean diagrams, the AND gates, OR gates, NOT gates, and other functions as well. So this video and in the next video, I'll be explaining all of that. So starting off with laws of Boolean algebra, so I'll be explaining the concept to you. Boolean algebra is a branch of mathematics that deals with algebra that is concerned with ones and zeros, which represent true or false. The 1 standing for true and the 0 standing for false of an operation. So another way to see this is the 1 representing something and the 0 representing nothing. This is just one way to visualize Boolean expressions, but then I can't promise that this would work in all instances. But this helps for you to understand the laws of Boolean algebra. So let's just get straight into it. So as you can see, I've written down some of these laws, basically the ones that will help you the most in simplification. So the first law here is, or probably principle, is that 1 dot 1. Now this dot represents the AND operation or function, either way. So the AND operation, AND, is represented with a dot. Now this function will give an output of 1 when either side of the function is 1. So in essence, what I'm saying is if the inputs that this function gets are 1 on either side, you have an output of 1. To simplify this, let's refer to this definition here. We said 1 is equal to something and 0 is nothing, right? So here we can just say something. Now you can see this as a multiplication sign, like in mathematics, dot, for the time being. It's actually the AND function. For you to understand this, let's just assume that this is a multiplication sign. It is something multiplied by something. That's something, right? So we have something multiplied by something is something. 1 and 1 is equal to something. 1. Pretty easy, right? Let's move on to the next one. You have something multiplied by nothing. You don't expect to have something here. You're supposed to 0, that's nothing. So something multiplied by nothing, 0. Whereas 1 multiplied by 0 is nothing. Now let's move on to the next function here. You can see we have the OR function, which seems like a plus sign. So in the same way, it works just like plus sign here in this context of laws of algebra. But as time goes by, you find that it might not work that way. Just need to keep the concept in mind that if either side is 1, either side of this operation, either side is 1 or true, either side happens to be true, it will give an output of 1, which is true. That's the OR function. The AND function, AND function will give an output of 1 when either side, when both sides is 1. So both sides has to be true for the AND function to give you a true value of 1. So let's go back here and see what we can do. We have 1 plus 1 equals 1. Now you see why I said thinking of it as an addition wouldn't help you, because in normal mathematics, in general algebra, you can have 1 plus 1 equals 1, it's 2, right? But here you have to see it like something or a true value. So you have true plus true will give you 1, or something plus something will give you 1. Here too you have 1 plus 0 equals 1. 1 0 equals 1. This correlates with algebra generally because 1 plus nothing will give you 1. So you have something plus nothing give you something. So another thing we have, you notice the a here. This a is a variable. Another kind of input you can have in Boolean algebra is a variable. So I can represent the variable with any letter. It could be a, it could be b, it could be c, it could be Greek letters, it could be anything at all. So now variables can assume two values. They can either be zeros or 1, meaning they can either be true or false. So let's see what we can make of that in defining laws of Boolean algebra. So we have a variable here. We don't know what value is it, but we know it could be 1 or 0. So in order for us to evaluate what a plus 1 would be, we have to test the values of the possible values of this variable as 0 and 1. So when a is equals to 0, when a equals 0, you have a plus 0 equals, so let's test it out. When a is equals to 0, you have 0 plus 0, which will be 0. That's nothing or nothing. Nothing plus nothing will be nothing. And when a is 1, you have nothing, something plus nothing to give you 1, just like in normal algebra. So now you can see that we have two different values as well. We have zeros and we have 1. So, and you remember I said a variable can assume either of these values. So in essence, what we are saying is a plus 0 would be equals to a. So that's what we've done here for the 1. So we have a plus 1 equals 1. So if you test it out, you have 0, 0 or 1 is 1. If you have 1, 1 or 1 would be 1 from here. So that's the same thing. Now we have a dot 1. The dot here representing the AND operation. So you have a dot 1 equals 1. So you can prove that as well. You can have 0 or 0 and 1, which would be 0, and you can have 1 and 1, which would be 1. So you have two different values, and a can assume two different values. So a dot 1 will be equals to a. So a dot a is equals to a. So basically, if you can remember all of these principles here, if you know all of these, you can actually just derive the rest yourself. Same thing here is what we've done here throughout. For example, here we have a and a to be equals to a. So we have, if a is equals to 1, then we can expect this a to also be equals to 1 since they are both a's. So you have a and a to be equals to 1. If you test it for 0, a and 0 and 0 will give you 0. So we have two different values. A can assume two different values. That would be a as well. Now, another thing we need to talk about is the inverse of, or the reciprocal of, a variable, which is represented by a bar. So a bar is just the inverse of a reciprocal. So basically, a bar is the output of an input that has undergone a change with the aid of inverters. I'll explain that later on as we go. So a inverse is just the opposite of a. So if a is equals to 1, you can expect a bar to be equals to 0. That's just that. And if a is equals to 0, a bar should be equals to 1. So here, if a bar, we have a bar dot a is equals to 0. So it's the general rule that inverse of a variable multiplied by that same variable will give you 0. So if you can test that out as well. So let's just do it. So assume that this is a 1. If a bar is 1, then our initial variable should be 0, right? So you have 1 and 0. That's 0, right? Then if you try it the other way, you have a bar to be equals to 0, and the initial variable will be the opposite of that, and that would be 1. So you have zeros and 1, and that would be 0. So since it's 0 for this, since you have the same outputs for the two different possible scenarios, so we can conclude that it's 0. You can try that for this one as well and you get 1. So you just basically need to keep all of these laws in mind and you should have no problem at all. So now that we have that covered, let's go to some actual simplification of Boolean algebra. So I'll just so we have some questions here and we'll be asked to simplify these Boolean expressions here, A to D. So I'll be showing you how to do all of this. It's really easy. So if you have any questions, just put them down in the comment section below. So let's get started. So now from the first question we have A dot B plus A dot B bar. So these are all variables. Now you just need to keep all the laws in mind. So you could decide to add brackets if you want. So now note the functions in there. We have the AND functions and we have the OR. And we already know what they do. So let me just write that down as you remember. We have both. Plus we have the AND. So this will only give you an output when of true when either side is 1. So either side has to be 1. This will give you an output. Both sides has to be 1 for you to have an output of 1. Either side has to be 1. So it could be this side, it could be this side, it could be both sides, but either side should be 1 for you to get an output. Or you can just say something plus nothing will give you something, and something times something will give you something. So let's get started. So as you can see, we can just open up this. We could open up this bracket like this distributive laws. So we are just going to apply that. So you have, you can open this up with A dot A. You could also have plus A dot B bar plus B dot A plus B dot B bar. So all I've done is like just multiply these values here. I just open up the brackets basically. So you have to note the signs here. However, you shouldn't expect to have to get negative signs in Boolean algebra. They're just plus or through. So if you're opening brackets like this, no worries. So here we can use some of our laws to simplify. If you recall, we have that A dot A should be equal to A. So you have A here plus A dot B bar plus B dot A plus B dot B bar, which if you recall should equals 0. Let's test that out. So you can have 1 here. If B is equal to 1, the inverse of B will be 0. So you have 1 and 0, which is equal to 0. And if you have 0 here, which will be 0, then the inverse should be 1. So you have 0 and 1, which will be 0 still. So this would evaluate to 0. So we write that as A plus A dot B bar plus B dot A. So this was 0. So this is just be 0. So from here I can factorize A out. I have 1 or B inverse or B bar plus B dot A. Now here, if you remember this, there's a law that says that 1 plus a variable or the inverse of that variable would give you 1. So you can try that out. You can test that out. So if B bar, we don't know what B was, so you can just assume both values here. So if B bar were to be 0, that means B was 1. So if B bar were to be 0, you have 1 or 0, which is 1, and if b bar were to be 1, you would have 1 plus 1, which is 1 still. So a times 1 will be just 1. Oh, sorry, more compactly, let me just write that. So you have a dot 1 plus b dot a, and you can apply the same Boolean laws here. So we know that a variable in dot 1 will give you that variable still. So we have a plus b dot a. So we've simplified this expression. Now note, however, that this expression and the initial expression remains the same way. If we drill the truth tables out, we would have the same values here, the same values in terms of zeros and one. So it's literally the same thing, but we could call this the disjunctive normal form, D or DNF. So this is just a simpler form of the DNF here. So basically we're just trying to simplify this to a more compact expression. So let's go ahead and try the second question here. So we have a plus a bar plus dot b bar here. A plus a bar dot b bar. So it will be, let's say, first bracket here, so we don't get the wrong idea. So now what I meant was that, merely saying this now, you could say that a plus a bar from the law, which is 1 or 0, be 1, 0 or 1 be 1. You could literally just use that law and assume that this part is equals to 1, and then you say 1 dot b inverse just b, which would be wrong because we have this in a dot relationship with this other variable here. So we can't just assume that this part will be equals to 1. So rather have to open up the bracket with this variable here. So that's what I'll be doing here. So I'll just like a plus. Now note that we have the plus function here. A plus a bar multiplied by, which is dot here, a plus b bar. Now from here we can simplify. We know that the law says that a plus the inverse of a variable, or the inverse of that variable, would give us 1. So you have 1 multiplied by a plus b bar, which from law will also give you 1. So that will be a plus b bar. So we've simplified this expression that way. Now let's move on to the third expression. And simplify that as well. I'm sorry, I have to switch over. Excuse me. Yes. Alright. So let's see. So let's simplify C. Have a C bar there. Now we're just going to do the same thing as before. So you know that we had to open up the bracket with the plus sign in front of it and then simplify further. So that's what we're going to do here as well. So we have a or a bar dot a or b bar dot a or c bar. Now we know from the laws that this would evaluate to 1. I have 1 dot a b bar. Now you could add the brackets just to be safe. Now this would a dot this would just be this, then in dot this, and from here we might have to open up the bracket. We have to simplify further by opening the brackets up. So we have dots here right in the middle. So we would have that was a mistake. We would have a plus a dot excuse me, that would just be a dot a plus a dot c bar plus b bar dot a plus b bar dot c bar. So from here we know that this would be equal to a, and that, so just rewrite this part back. So from here I can factorize a out, and I have 1 or c bar. I'm just going to rewrite this part. Now this will evaluate to 1, and I have 1 plus b dot a or b bar dot c bar. And I could also factorize a out of here again, so you have 1 or b inverse plus this, which, as we know, just like this, would evaluate to 1. So you have a dot 1 plus this will evaluate to 1, and you have a dot 1 or b bar dot c bar. This would give you a or b bar dot c bar, and we are done. So we have one more question here. I hope you guys can see clearly. We have one more question here. So I'll be leaving this question for you guys to solve. I'm trying to see if I can adjust the screen. Alright, so you have a dot b dot c or a dot b bar dot c or a dot b dot c bar or a dot b bar dot c bar or a bar dot b bar dot c. So I'll be leaving that question for you guys to solve till the next video. So in the next video I'll be showing you guys how to construct truth tables, and I'll be showing you how to use expressions, Boolean expressions, to construct circuitries using the or, the AND gates, NOT gates, and we'll be seeing other gates as well. So thank you very much for staying with me on this one. See you in the next video. Please like this video, share this video, and subscribe to my channel. Till the next time, peace out.